Hello everybody, I am Alex Teal and I am a huge desktop robot arm nerd. And I can't tell you how excited I was when the fine engineers at Elephant Robotics sent me 2 of their desktop robot arms from the MyCobot line. So today I will be going over the M5 stack MyCobot and the Raspberry Pi edition MyCobot. And I'll explain what all this means, but I'll also be going over some of the quirks on these robot arms, their capabilities, the grippers that come with it, and exactly why someone might want a 6-axis robot arm for themselves. So let's jump right into it. Okay, so before I start showing cool robot arm action, let's go over exactly what you get in the box and kind of what's going on here. So very first of all, this is the base. So we've got one joint here, another joint here, another joint here, another one here, another one here, and then finally the final one there, right? So that is 6 axes. All of these joints have limits except for this one, which can rotate freely forever, which makes sense because the joints between each of these has to carry wires to the next joint, to the next joint, to the next joint, and this one can just spin. What's also nice is all of these joints have feedback, so you know exactly what angle they are at any given time. Now, this is a $600 robot arm, not a $20,000 robot arm. So the accuracy feedback you're gonna get is not gonna be as high fidelity as a, industrial robot arm. You're also going to get a bit of backlash on these servos. It's not perfect. With that said, it's actually pretty accurate. The website states that there's a repeatability of 0.5 millimeters. I think repeatability is one of those things that can vary significantly depending on how you measure it. So take that with a grain of salt. The payload is 250 grams. So that depends on how far the payload is from the robot. Of course, the closer it is, the higher the payload. The further it is, the more of a lever arm you have going on there. Working radius, 280 millimeters. So let's jump into how you actually mount this thing. So this is a really cool part of this robot arm. See these parts on the bottom and right here. So these are actually compatible with like Lego Mindstorms type of parts. So this is the base. And the idea is you just stick these very familiar Lego rods and you can just slap that onto the base. So once you've attached that, you can get a regular old clamp and clamp this onto a table. So that's how I had that for the very introduction of the video. So you just clamp that onto a table. But what's also cool is because you have it on the end effector, you can make your own end effectors for this robot and just put Legos in here to attach them. So let's test that out. So for example, here I've got some Lego pieces and I've got this gripper. So I can just stick the Legos into here and whatever pattern I want. You might want to put more, I don't know. And then you just attach it to there. So then all that's left is to actually wire this to the end of the robot arm right here. So what else do we have going on here? Right here, we've got a 5x5 LED screen. So this is actually part of the M5 stack. I think it's called the M5 stack Atom. And so you can actually flash this using the USB-C there and put little programs on here. You can also control the LEDs directly from the main board on here. So speaking of controls, let's actually talk about the difference between this and the other robot. So the main difference between these robot arms is that this one has an M5 stack controller here. So this comes with a little screen. It's got different I/O, USB-C, some buttons that are built in. And that's cool. And that's also useful for most people who want to do Blockly programming and they just want to drag and draw programming. But for more technical people or just people who are more into Raspberry Pis or in the maker scene, this robot has just a straight up Raspberry Pi. This is just a Raspberry Pi stuck inside of a robot arm. You've got all the usual I/O, HDMI out, everything. This is a vanilla Raspberry Pi. So that's pretty cool. I like Raspberry Pis. I like the idea of having my robot have an entire computer inside of it. And I'm a computer vision guy, so I like to run computer vision algorithms. So having this one makes a lot of sense. If you are not a programmer, you're not familiar with Linux, or you've never used a Raspberry Pi, this might be a good starter for you, especially if you're going to have your robot plugged into a computer all the time anyways. So let's go ahead and test these things out and see them in action. So let's get one of these set up. I'm going to set up the M5 stack one. And I think I'll just start by clamping this to the desk and getting it plugged in. Well, the very first thing you'll notice about this M5 Stack 1 is that because it's got a screen and some buttons, it's actually usable right out of the box. So unlike the Raspberry Pi, you don't have to plug in a monitor in order to do anything. So I like that because we can go ahead and just start recording and playing back things on the robot. So I'm gonna go ahead and click record. I'm gonna say record RAMs, and then I'm gonna move the robot around and we're gonna see it replay that. So the way that the recording works is internally the robot has encoders that track the position and angle of every joint. And I can only presume that on the open source firmware, you can probably confirm this, but that it's just recording and logging the positions of every angle of every servo, and then once you play it back, it plays those back interpolated to some safe speed. Okay, now that I've recorded something, I can go ahead and press play and it will play it back. So thank you so much for watching. This is the end of part 1 of the review video. In the next part, I'm going to be doing some kind of computer vision project that'll involve Python, a camera, and this robot. So if you have any good ideas for me, please put them in the comments. One thing I'm thinking about doing is just making a poker playing bot that recognizes the cards, lays them out, and acts as a dealer during poker.